All right, so now we're going to look at factoring trinomials where a equals 1. When I say a equals 1, I am talking about the leading coefficient of a quadratic trinomial. So the coefficient in front of the x squared term is 1. All right? Tomorrow we'll talk about when it's not equal to 1. What do you do? So here's an example. X squared minus 5x plus... The problem is I can't put it back after it does that. Okay. X squared minus 5x plus 6. Okay, so here's what we do. We do a diamond problem. And in this diamond problem, we're going to put a times c up here and b down here. Now, what is the a, b, and c? Our a is 1, our b is negative 5, and our c is the constant term, which is 6. So for this example, this is going to be 6 times 1 goes up here, and b goes down here. All right, do you remember doing diamond problems back in September where we have to figure out what two numbers multiply to be the top number and add up to be the bottom number? That's what we're going to try to figure out here. So what two numbers multiply to be 6 and add up to negative 5?
3 and 2.
Yes. And what would the signs on 3 and 2 be? In order for them to add up to negative 5. They're going to have to be negative, right? Negative 3 and negative 2 add up to negative 5. Negative 3 times negative 2 is positive 6. Okay, so this is step 1 of the process. Step 1, do the diamond problem. Step 2, we're going to use an area model to help us factor this. And when I say factor, what this is going to look like, because it's a trinomial, is going to be two factors that are binomials. And we're used to that because you're used to multiplying those out using the area model. This time, we're factoring, so we're working backwards. So what we do is we put the first term here, ax squared goes there, the constant term goes here, and the numbers we get from our diamond problem tell us what to put here in these corners. It doesn't matter what order we put those in, so I could have put negative 2x up there, negative 3x down there, it doesn't matter. You'll get the same answer. So, now what we do is I recommend starting at this corner, and we're trying to figure out what times what is x squared. X times x is x squared. So if you think of this little box here, you're finding the area of this little box. The area is x squared. You already know the area. The dimensions would be x by x. And then for this one, x times what is negative 3x? Negative 3, we put that there. Down the side here, we're doing x times what is negative 2x? Negative 2. So this factors as, well, first of all, let me label that. That's step 2. So this factors, what we do is we read the dimensions of the box. And these are our two factors. All right. It kind of looks like someone just threw up alphabet soup on my page here. Multicolored. That's gross. Let's move on. Okay, let's do another example. Or do you want me to pause? So let me pause in case you're ready. Okay, so now we're going to do this one. So the first step is to do a diamond problem. And I'm going to do A times C on top, which A is 1, alright, so it's basically just C because C times 1 would be C. We'll put B down here. Again, this is our B, this is our C, and our A is 1. Alright. Next, we have to figure out the diamond problem. So what two numbers will multiply to be negative 21 and add up to negative 4? So you don't want to start with what adds up to negative 4. You want to start with what multiplies to be 21. So if I think about the factors of 21, that would be like 1 times 21, 3 times 7. Those are my options. So what should I pick and to go on the sides here? What two numbers multiplied to be negative 21 add up to negative 4? This is going to be negative 7 and positive 3. Okay. Now we're doing this box thing. We put our squared term here and our C goes here. And then negative 7x and 3x go in the other two places. And again, I'm getting those from my diamond problem. So starting at this corner, what times what is x squared? That part's easy, it'd be x times x. And then moving over here, x times what is negative 7x? Be negative 7. And then x times what is 3x? Positive 3. So my answers are, I should say my answer is x plus 3 times x minus 7. Any questions on this? All right, let's look at this one. Okay, so what goes on top of my diamond problem? And you know what? I'm going to write it out again. And I'm going to write, this is like the generic, okay? So if I had a notebook I was keeping for this class, I would put this stuff down. That's supposed to be an A. Okay, so this is the generic form. But so for this problem, let's see here.
So writing down the generic might be helpful for you guys to have that. Miss Bruce, do you mind writing the generic of the original, the like a x squared plus bx plus c?
Oh, good idea.
And so that's where these a, b's, and c's come from. And so if you have that, the generic, that's like the rule. And that can help you because no matter what problem you do, that A, B, and C will apply to each diamond or X box. I like to call it an X box.
Yeah. Not the PS5.
Mm-hmm.
All right, so in this example, A is 1, C is 16. So A times C is 16, and I put that up here. And our B is 10, I put that here. So we're looking for two numbers that multiply to be 16 and add up to be 10. Two numbers that multiply to be 16, add up to 10. That's right, 2 and 8. Okay, now what do we do with that? We're going to do this little box thing here. Ax squared goes here, so that's x squared. C goes here. And then the other two corners I get from my diamond problem. 8x and 2x. Okay, lastly, I do this. I think what times what is x squared? X times x. X times 8 would be 8x. X times 2 would give me 2x. So my answer then, so I'm going to write the whole thing out. So here's what this trinomial, it's got 3 chunks to it, call it a trinomial, looks like before it's factored. And x plus 2 times x plus 8 is how it looks after it's factored.